This video is going to walk us through the setup and configuration of the HydroFORM corrosion mapping system. We start with File, New, to load the default new file settings for the OmniScan. Go to the wizard, Setup, Start. We will modify the default phased array channel. The probe is automatically detected. Select the wedge from the database and note the height of the first element and primary offset. Continue in the wizard. Set the index offset position to the first focal law. Continue for the programmation of the focal laws. Select linear at 0. The inspection will be an L-wave velocity of carbon steel. A custom velocity can be entered under the UT menu. Select a 4-element aperture using the 1st through 64th elements with a 1-element step. Enter a shallow focal depth, and we will configure the gate after the UT. Generate. This will produce the phased array group. Change the display to the A, S, and C scan with C scan off. Here we have the pipe to water interface, a series of back walls, and the second wedge echo. Continue to the UT setup and enter a negative start so we can see the water column. We can see that the water column is free of bubbles and the interface. Select a range of approximately 3 back walls. Continue to the pulsar. We will use low energy and optimum PRF. Under the receiver, select the filter closest to the frequency of the probe and video filter on. Under the Advanced tab, change our point quantity to 640. Lower the general gain until the surface interface backwall is approximately 100% amplitude. Continue to the gate configuration. Select Gate I. This is the yellow interface gate. Enter a start of approximately -3 millimeters with a width long enough to ensure the interface will be detected. Under the mode, change the interface signal to synchronization on echo. This will ensure a flat interface and will ensure, regardless of probe instability, that each focal law starts at exactly 0. Shake the scanner slightly to remove the bubbles. Continue configuration to gate A. Change the mode to leading edge. For position, position the gate directly over the first interface as close to the interface signal as possible. This gate will monitor the first back wall. Under Gate A mode, we will see we're measuring the leading edge signal and it is synchronized to the I gate, creating a floating gate. Do the same for Gate B to cover the second back wall. Under mode, we are synchronized to the I gate and we're taking the leading edge measurement. Under the thickness tab of the gates, we want our source of the reading to be A minus I and enter a range for the intended thickness. This can be changed after the inspection in analysis mode while performing analysis. Continue the setup to the display. Activate the C-scan. Under View Settings for the C-scan, choose Source 1 Thickness, Source 2 A%. Under Properties, select the color palette, Depth, and enter the range for the inspection. Continue to the Sizing tab, where we will build a manual TCG to increase the amplitude of the back walls without increasing the amplitude of the surface interface. Select TCG, Curve Setup. Move the position of the first TCG point out of the surface interface signal. Add TCG point 2. Use the position of the first back wall and increase the gain until the signal is approximately 100% amplitude. Add the third TCG point. Enter the position of the second back wall and increase the gain until the second back wall is approximately 100% amplitude. Continue to the Scan menu and change the inspection from Time to Encoder 1. The clock icon will be replaced by the mechanical icon indicating the PRF now is tied to the encoder. Our scan axis will be Encoder 1. This will be the circumference of the pipe. Change type to raster scan, allowing a 2-axis inspection. Enter the resolution of Encoder 1. Enter the resolution of Encoder 2. Be sure and consult your scanner manual or calibrate the resolution if it's not known. Under the Area tab, enter the circumference under the pipe for the scan axis. A scan resolution of 1 millimeter on the mechanical axis. For linear 0 mode, the index is automatically calculated as a function of the aperture. Enter the number of strokes. The third stroke will be 122 plus the 60 millimeter stroke. Ensure that the index axis from 0 to 183 in this case, and the scan axis from 0 to 1025 is correct on the C-scan. Continue to the File menu and save the setup file. Under our data settings, ensure we are saving the A and C scan to the storage card or USB device. Enter a file name. The OmniScan is now prepared to start the inspection. Select the arrow key on the right-hand column to start the acquisition. This will reset both encoders to 0 and the instrument is ready to begin the inspection.
Grab the chain scanner with 2 hands, and place it around the circumference of the pipe, keeping it as parallel as possible to the pipe surface. Reach around with 1 hand and grab the hook and set it and clasp it tight. We'll flood the water column shake the scanner to ensure it's free of bubbles. We will use the C-scan layout for the inspection. Hit the Start Acquisition button that will reset the encoders, and we're ready to start acquiring data. Move the scanner slowly and smoothly. If you miss any lines of data or have a problem, you can back the scanner up. It's writing data in both directions. We complete the first stroke back to the start position. While watching the index axis encoder, I'm going to scoot the scanner over on the index axis to 60 millimeters with about a 1 millimeter overlap between strokes. And begin acquiring the next acquisition. Again, while watching the index axis, I'm going to move the scanner over another 60 millimeters. Ensure that we're not missing any data. We have enough overlap. Bring the scanner all the way around back to the 0 position. And the data file is ready to be saved.